Okay, so imagine this for a moment. Four humans leaving Earth behind, not just traveling into space, but moving farther than anyone has in over half a century. No cities, no signals, no sound, just a spacecraft and the silence of deep space. They're not going there to land, not yet. They're going to witness something humanity has only ever studied through machines, the side of the moon that never faces Earth. Number 10. The launch no one thought would happen. To understand what happened on April 6, 2026, we need to rewind a few days. On April 1st at 6:35 p.m. Eastern Time, the Space Launch System finally lifted off, a moment that for years felt uncertain. This wasn't a normal launch delay story. A winter storm had already pushed schedules back. Then came a hydrogen leak during a critical countdown test, a small issue with massive implications. And above all, there were concerns about Orion's heat shield. During the previous uncrewed mission, engineers detected unexpected erosion after re-entry. Not catastrophic, but not fully understood either. And in missions like this, not fully understood is never comfortable. So the question became unavoidable. Was it safe to send humans? For weeks, teams debated, simulated, tested. They reviewed data, ran models, challenged assumptions, until finally, they reached a conclusion. Not perfect certainty, but enough confidence to move forward. And when the engines ignited, it wasn't just a launch. It was a decision built on years of doubt. Number 9. The most advanced spacecraft built for deep space. Orion isn't just a spacecraft. It's a test of human capability far beyond low Earth orbit. Because going to the moon isn't the challenge anymore. Going safely and coming back reliably, that's the real objective. Inside and outside the capsule, systems are constantly being monitored. Cameras record everything, not for spectacle, but for analysis. Every movement, every reaction, every anomaly. But the real focus goes deeper. Life support systems under isolation, navigation without constant Earth reference, decision-making delays. Because in deep space, you're not seconds away from help. You're minutes, sometimes more. And that changes everything. Every system on Orion is designed with redundancy, backups for backups, because out there, there's no room for improvisation. This mission isn't proving we can go, it's proving we can survive the journey. Number 8. What they eat 400 kilometers from Earth. Now, here's something that seems simple, but isn't. Food. Not just what you eat, but how it affects performance. In space, eating isn't casual, it's operational. The crew's menu is carefully engineered. Tortillas replace bread, no floating crumbs. Nuts provide compact, long-lasting energy. Protein-rich meals support muscle preservation. Even small details matter. Texture, packaging, ease of handling in microgravity. And yes, there are small comforts. Coffee, desserts, familiar flavors. Because morale matters too. But every item has a purpose. Calories are measured, hydration is tracked, nutrient balance is controlled. Because in deep space, a small deficiency doesn't stay small. It compounds. Fatigue builds, focus drops, and mistakes become more likely. Out there, food isn't just fuel, it's stability. Number 7. The scientists you never see. While the crew travels through space, they're never truly alone. Back on Earth, entire teams are watching, not passively, but actively interpreting everything. Every image sent back is analyzed within seconds. Surface features, light variations, unexpected patterns. This isn't just observation, it's real-time science. Specialized teams focus on different aspects: geology, radiation, surface composition. Each detail the astronauts notice is immediately expanded by experts on the ground, because human eyes see one thing, but combined with data, that observation becomes knowledge. This connection between crew and Earth is what turns a mission into discovery. Without it, you're just passing by. With it, you're learning in real time. Number 6. The moment Earth disappears. There's a moment in the mission that no training can fully prepare you for. As the spacecraft moves behind the moon, Earth disappears. Not gradually, not partially, completely. This moment has a name: Earthset. For the first time, there is no visual connection to home. No blue planet, no continents, no light. Just darkness and the surface of another world. It's more than visual, it's psychological. Every reference point, gone. And then, slowly, something changes. A faint glow appears, and Earth rises again. Small, distant, fragile. A reminder that everything we know exists on something that now fits in a window. Number 5. The side of the moon we never see. For hours, the crew observes something very few humans ever have: the far side of the moon. Not captured through instruments alone, but seen directly. This side is different. More craters, rougher terrain, fewer flat plains. A surface shaped by billions of years of impacts without the same geological smoothing seen on the near side. Among the regions of interest, massive impact basins. Structures so large, they redefine the surface around them. These formations help scientists answer key questions. How did the moon evolve? Why are its two sides so different? What does this tell us about other planets? Because the moon isn't just a destination, it's a record of the early solar system, and reading that record requires being there. Number 4. 40 minutes completely alone. At a certain point in the mission, communication stops, not due to failure, but physics. The moon blocks the signal. For about 40 minutes, there is nothing. No updates, no confirmation, no connection to Earth. Inside the spacecraft, everything continues as planned. But psychologically, it's different. Because for that window of time, they are completely on their own. From Earth's perspective, they've disappeared. No tracking, no voice, no reassurance. And when the signal returns, it's immediate. Voices reconnect, data resumes. But those 40 minutes remain, a reminder of distance, not just in space, but in communication. Number 3. The flashes in the darkness. In the absence of atmosphere, the moon reveals something subtle: impacts. Tiny meteoroids striking the surface at incredible speeds. From a distance, in darkness, they appear as brief flashes, short, sharp, easy to miss, but incredibly valuable. Each impact carries information: frequency, energy, distribution, data that helps estimate risks for future missions. Because on the moon, there's no atmosphere to burn objects up. Everything reaches the surface, and if humans plan to stay there, they need to understand that environment. These small flashes are warnings and lessons. Number 2. Watching the sun differently. In deep space, observation changes. Without Earth's atmosphere, light behaves in a raw, unfiltered way. Under certain alignments, the spacecraft can observe the sun differently, not directly, but through indirect exposure and shielding. This allows glimpses of outer solar layers that are normally difficult to study from Earth. Subtle variations become visible. Changes over time become trackable. These moments are rare, short windows where conditions align perfectly. And when they do, they offer something valuable: time. Time to observe, time to record, time to understand processes that usually pass too quickly to analyze. Number 1. The farthest humans have gone in decades. The defining moment of the mission: distance. The crew travels farther from Earth than any human has in over 50 years. Beyond previous missions, beyond familiar boundaries. At that distance, Earth isn't a place, it's a point. Small, distant, alone. And yet, everything we've ever known is still there.
This milestone isn't just about breaking a record. It's about proving something fundamental. We can go back. And more importantly, we can go further. This mission isn't the destination. It's the test. Because the next step is returning humans to the lunar surface. And beyond that, building something permanent. A base, a foothold, a starting point. Not just for exploration, but for expansion. Because space is no longer just something we observe. It's something we're beginning to reach. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.